In this lesson, we'll derive the condition for constructive and destructive interference. After deriving the conditions, then we will define our coherent and incoherent sources of light. So coming to our first question, derive the conditions for constructive and destructive interference. So in our last class, we have derived the equation for this intensity. Okay, this intensity equations tells us about the intensity, whether it will have a maximum intensity, or let us say whether it will have maxima, or whether it will have a minimum intensity, this dark fringe. Okay, this is minimum intensity, this is minima. So this intensity expression tells us whether at any point on the screen, whether it will be your maxima, your bright fringe, or whether it will be minima, your dark fringe. Right? Where in this equation, the I1 denotes the intensity of the light coming from your slit S1. I2 denotes the intensity of the light coming from the slit S2. Okay, beta I1 denotes the intensity of the light coming from slit S1. I2 denotes the intensity of the light coming from your slit S2. Fine. And this phi, okay, this phi represents the phase difference between the light coming from your S1 and your S2. Fine. Now, since the interference, okay, this intensity equation depends on these three terms: the first term, the second term, and the third term. Now, look at your first term. Since the light is coming out of this first term, therefore, this is a positive quantity. That means it will always be there. Fine. Whether be it very low or very high, but it will always, the light will always have some intensity. Similarly, for your I2, the light coming from the slit 2 also will have a intensity, whether be very low intensity or very high intensity, but it will have a positive intensity. So the question is arising how we are getting maxima at some points, minima at some points. So this interference depends upon this third term. Can you see? Where your third term 2 root over I1 root over I2 cos phi is known as your interference term. If this term is maximum, then we will have a constructive interference. If this interference term is minimum, then we will have a destructive interference. So let's first derive the condition of this constructive interference. So as we know, this I1 term and this I2 term will be constant, but what will be varying or what will be changing? Your cos phi term. Fine. So you know the cos phi term. Okay, let me take you to the graph. Okay, so this is your cos wave curve. Okay, you know at cos 0, cos of 0 is how much? 1. How much is cos of pi by 2? Cos of pi by 2 is 0. So this curve, can you see this wave structure? This represents your cosine wave. Fine. So let's look at the values of cos. Okay, so at 0 you have 1. At pi by 2, cos of pi by 2 is how much? 0. Cos of pi is how much? -1. Cos of 3 pi by 2 is how much? 0. Cos of 2 pi is how much? It is -1. Fine. Similarly, let's go. Cos of 3 pi by 2 was 0. Cos of 2 pi is 1. Cos of 5 pi by 2 is 0. Cos of 3 pi is -1. Cos of 7 pi by 2 is 0. Fine. So these are the values of your cos wave. Okay. So this cosine wave is not something new. Okay, you have been already doing this in your maths. Okay, in your trigonometric chapter, where you have memorize the values of this cos wave. Okay, I'm just showing you the pictorial representation of this cos. So for the cos 0 you had 1, cos pi by 2 0, and so on. Fine. Now if you look here, look at these values. Fine. Look at these values and tell me what is the maximum value a cos can have. Whether cos can have a value 2. Is there any point, or is there any point where this red curve intersecting this line? No. The maximum value it can take is 1. Can you see this 1? At the point when it reaches 1, fine. After that, what happens? It starts to decreasing to 0. After decreasing 0, it decreases to -1, and then from -1 again it starts to increase to +1. Fine. So what is the maximum values it can take? The maximum values are your 1. Fine. But now the condition arises when it can take the maximum value 1. Look here, cos 0 is 1, cos 2 pi equals to 1. If I shorten this curve, okay, 0, 2 pi, at 4 pi, at 6 pi, at 8 pi, 10 pi. So from here, look at these points and tell me, when will be the cos value will be 1? The cos value will be 1 when it is a even multiple of pi. Can you see? 2 pi even multiple, 4 pi even multiple, 6 pi even multiple, 8 pi even multiple, 10 pi even multiple, and so on. Fine, and so on. So for all the even multiples, you will have the plus 1 values. Okay, fine. Can you see all the even multiples of pi? Now, why we are so interested in the cos, the 1 value? Okay, look here. If cos is 1, the maximum value of cos is how much? 1. If this term has the maximum value, then what happens to this term? This interference term will also have a maximum value. If this interference term has the maximum value, then as we already know, this is a constant, this is a constant. So obviously your intensity will also be maximum. Therefore, you will have a maxima. Fine. Let's take the opposite case. If this term cos phi, if this cos phi term is minimum, what is the smallest value your cos can take? -1. So if this term is smallest, minimum, then this interference term will also be minimum. If this interference term is also minimum, we know this is a constant, this is a constant, this is a constant, this is a constant. So it doesn't depend upon the constant, but it depends upon this cos phi term. So if this term is cos phi is minimum, then this third term, your interference term, is minimum. If interference term is minimum, then all of this intensity, that means this equation I will also be minimum. Therefore, at this point, you will get a minima. So our constructive interference or your destructive interference, or I can say your maxima or your minima, depends upon which term? Your interference term, and in particularly which part? This one, cos phi. So for constructive interference, what should be the condition? For constructive interference, the cos phi term should be equal to 1. Then only we'll get a bright spot here. Fine. Fine. So cos phi will be 1 for which values? Cos phi will be 1 for all the even multiples of the pi. Fine. So let me write these values. It will be 1 for 0, for 2 pi, for 4 pi, for 6 pi, for 8 pi. Let me write these values here. So cos phi equals to 1 when phi equals to 0, 2 pi, 4 pi, 6 pi. Fine. Fine. So if your phase difference is 0, phi equals to 0, that means the wave traveling from here and the wave traveling from here travels a equal distance. That means There is no phase difference between the waves. Therefore, at this point, you will get a maxima. That means at this point, you will have a central bright fringe. Fine. So for the central bright fringe, the phase difference between the light coming from slit S1 and S2 should be how much? 0. Or I can also say the path difference should be same. Let us look here. Suppose you have one wavelength, two wavelength, three wavelength traveling. Fine. Similarly, from slit S2, one wavelength, two wavelength, three wavelength. Fine. So since the phase difference is how much? 0. Therefore, the light is traveling the equal path. Okay. The distance traveled will be same. That means here the light traveled three wavelength. Here also the light traveled three wavelengths. In that case, you get a central bright fringe. Fine. Fine. Now let us consider another point. Now look here. At this point, okay, how much will be the phase difference? The phase difference will be 2 pi. So if the phase difference is 2 pi, then in that case, okay, look here. Okay, so look here. Suppose the light is traveling from slit S1. So one wavelength, two wavelength, three wavelength, right? Similarly, the light is traveling from your slit S2. One wavelength, two wavelength, three wavelength, and four wavelength. Fine. So in this case, the light is traveling three wavelength, but in this case, the light is traveling four wavelength. Fine. So there is a difference of how much? There is a difference of one wavelength. Okay, so if you look here, look here. If you have a wave, okay, the light starts, let us say it starts from here, and this one complete cycle is known as your one wavelength. So how much extra phase difference can you see here? It starts from 0, it ends at 2 pi. So when the phase difference is 2 pi, that means the path difference is how much? The path difference is of one wavelength. Fine, so look here, let me just zoom in. Okay, fine. So when the phase difference is how much? 2 pi. So when your phase difference is of how much? 2 pi. The light has to travel a extra wavelength. Can you see this part? This is the extra path the light has to travel. So your path difference is lambda. Fine. So in this case also, since the difference is how much? Of 2 pi. Okay, there's not much difference. If this is a difference of 2 pi also, can you see the crest and the crest, they coincide, the trough and the trough coincide. In that case, you get a interference which will be a constructive. So at this point P1, you have a constructive interference. Fine. Now, for your next bright fringe, okay, for your next bright fringe, how much should be the phase difference? The phase difference should be of 4 pi. Now, if the phase difference is 4 pi, in that case, how much will be the path difference? Let's see. So suppose the light is coming from your slit S1. In that case, one wavelength, two wavelength, three wavelength, and four wavelength. And the light is coming from the slit S2, one wavelength, two wavelength, three wavelength, four, five, and six. So when the phase difference is of 4 pi, the extra path the light has to travel. Okay, let me just show this extra path with this green one. Fine, can you see this green wave? This is the extra path the light has to travel. And how much is this green wave? This green wave represents your two wavelength. So if it's two wavelength, that means one wavelength, two wavelength, and see how much is the phase difference. One wavelength up till this point, from here to here, and then two wavelength up to this point. So how much is the phase difference? 4 pi. So when the phase difference is of 4 pi, the extra path the light has to travel is how much? 2 wavelength. That is 2 lambda. So the path difference I'll write here is twice of lambda. Fine. And so on it will increase. Fine. So it will repeat similarly in this manner, and the same pattern will be observed in the downward direction. Fine. So this will continue here also. You will have a central, you have a first, you have second, you have third. You have some phase difference, corresponding path difference, phase difference 4 pi, path difference 2 lambda, phase difference 6 pi, path difference 3 lambda. Okay, let me just correct this one. Fine. So let me just write this values in a table, okay, for our better understanding. So when the phase difference is 0, how much is the path difference? 0. So when the phase difference is 0, the path difference, okay, this is your path difference. When the phase difference is 0, the path difference is 0. When the phase difference is 2 pi, the path difference is lambda. 2 pi, path difference is lambda. So when it is 2 pi, the path difference is lambda. Now look at the third case. When the phase difference is 4 pi, path difference is how much? 2 lambda. When it is 4 pi, the path difference is 2 lambda. Right? In similar manner, I can write if it is 6 pi, then it is 3 lambda. If it is 8 pi, then it is 4 lambda. Fine. And so on. So here, can you notice one thing? If this is a integral 1 times 2 pi, the phase difference is how much? 1 times of 2 pi. The path difference is also 1 times of lambda. Fine, can you see this here? Fine, now let's take a look at the second value. When the phase difference is 4 pi, that means 2 times of 2 pi. Then your path difference is also 2 times of lambda. When your phase difference is 3 times of 2 pi, the path difference is how much? 3 times of lambda. When the phase difference is 4 times of 2 pi, that is your 8 pi, the path difference is 4 times of lambda. Fine. So can you see a pattern is being repeated? Here 1, 2, 3, 4, and this is 2 pi. Here 1, 2, 3, 4, this is lambda. So let us say this n times of 2 pi, n times of 2 pi is equals to n times of lambda. Can you see? This n times of 2 pi and n times of lambda corresponds to the same value here. Fine. So let me just write down here. N times of 2 pi equals to n times of lambda. Fine. So from here, okay, this is your phase difference phi and this is your path difference p. So can I derive a relation between your phase difference and p? The answer is yes. Let us suppose if my phi equals to 2 pi by lambda times p. Okay, now let's see for this first value. When the path difference is, substitute p equals to lambda here. Substitute p equals to lambda. Then in that case, how much will be the phase difference? Use this value to calculate. Your phi will be 2 pi. Again, let us substitute path difference equals to 2 lambda. When path difference equals to 2 lambda, 2 pi by lambda divided by 2 lambda. This lambda gets cancelled. So I have 2 here. So 2 times 2 pi is how much? It is 4 pi. Therefore, your phase difference is coming 4 pi, isn't it? Fine. So I can use this general relation for this table, isn't it? So this is my general relation, okay? Okay, look at this derivation is not that much important, so I'll directly use this equation. But I've explained how I got this equation, okay? So let's just use this equation here. Fine. Okay, so look here, this 0, 2 pi, 4 pi, this 0, 2 pi, 4 pi, 8 pi, 6 pi, I can write it as n times 2 pi, isn't it? So let us say my phase difference phi can be written as n times 2 pi, or I can also write this one as twice of n pi. That means when my phase difference is in even multiple of pi, in that case what you'll get, you will get a bright fringe. Fine. So where your n ranges from which values, where n equals to 0, 1, 2, 3 and so on. Fine. So using this expression here, I can write 2 pi lambda p equals to twice of n pi. Now from here I can cancel 2 and I can cancel pi, and I can send this lambda to the other side. In that case my path difference p equals to n lambda. Therefore, when the path difference is a integral multiple of the wavelength, in that case you will get a constructive interference. So this one and this one are the conditions for your constructive interference. So the condition for your constructive interference at any point will be when your phase difference phi equals to 2n pi, or your path difference equals to n times of lambda. Fine. So if you remember, we have also used this condition for your bright fringe. Okay, so let's go back to your lesson number 31. This is your lesson number 31. In this lesson number 31, I have derived the condition for the position of the bright fringe. Okay, so look here. To obtain the position of the bright fringe, the path difference P should be the integral multiple of lambda. So we have used these conditions in your fringe width also. Fine. To find out the position of the central bright fringe. Fine. Now let's move to the next one, destructive interference.